welcome to the second day of Container Days. Today I'm going to talk about Dockerfile Best Practices. What I will do is to go over a real-life Dockerfile that I received some time ago from an job candidate, and we will go through it and make it better, let's say. My name is Koray. I work for Kubermatic, remotely from Istanbul, Turkey. I'm interested in Linux, Kubernetes, and all other cloud technologies. So before we start on Dockerfiles, let's recap or refresh our memories about what a container is. Some people use the term lightweight VM to describe it, but that's definitely not true. There's no need for a discussion. They are not lightweight VMs. So what they are is that they are processes. They are Linux processes born from tarballs, anchored in namespaces, and controlled by C groups. So they have their own file system, they have their own namespaces for PID, mount points, and network, etc. And you can control the CPU and memory usage with C groups. So then it comes the Linux container to save us all. So this is the Dockerfile that I mentioned. Maybe by just looking at very quickly, you can see there are issues in it. But to give you it's a spoiler alert, it works. In the end, what it's supposed to do is to run this app.py application, and it does it. But we can run it in a better way. So for the sake of this presentation, I made a few modifications for the whole project. And there are, in my project folder, there are some other files from Terraform, Ansible, and other Docker files that we will see later on. So let's build this. And when we build this, it takes, on my laptop, it takes 1 minute to create the image. But I don't know if you see anything strange here in this output. If you can take a look, maybe. Well, this strange thing here is this. So the context, which we stated at the end, the last dot that use the current directory as the context, and it sends almost 600 megabytes of data to the Docker daemon. And this also takes a few, like 10 seconds or so, and also it's too big, right? And if you remember the Dockerfile itself, in the end we copy the whole directory to the image. So this will be copied there probably. And again, checking with the my project tree, it's like there are only text files, right? Ansible playbooks, Terraform files, etc. But where does this 600 megabytes come from? I check it with disk usage and see that, Terraform, because I ran it locally and it downloaded some providers, etc. So it has some cache there. So that's the thing. And I will mention about a tool called Dive. With Dive, you can see what you have in your image with the layers. So it's you see there are two columns. On the left side, you see the layers there, and on the right side, you can see the whole file system, what you have. So in the latest layer, it's again 589 megabytes. And you see that my whole directory is copied there, all the Terraform providers, my Git history itself, and the rest. But this is something we don't want, right? We also don't want those kind of things with our Git repos, right? So we use git ignore to not to send local files to the real repository. So the same thing exists in Docker, and it's called Docker ignore. So if you have this, so there is another solution not to have those files inside your image. Well, you can, instead of copying the whole current directory, you can copy only the files you needed. But this doesn't solve the problem of copying everything to the Docker daemon itself. So at the very beginning of the build stage, it is not resolved. But if you put those files inside Docker ignore, then those will not be copied to the daemon itself, and they will not end up also in your image in any case. So if you build this one, this time it takes 52 seconds. So I already saved 10 seconds just by adding an ignore file. Plus, I don't have those important, let's say some secret files shipped with my image. So that is so you see that the context daemon now it's only 30 kilobytes and it took 52 seconds. So if you take a look at it again, dive, you see now the latest layer is only 14 kilobytes because now it's only the text files, the remaining text files are copied there. So, and also the image size itself. So if you remember, the first image size was 1 gigabyte, but now it's already 425 megabytes of data. So we accidentally copied our Terraform files, but they were not needed there. So this is something, so we haven't touched the Dockerfile itself so far. And there's another thing that you can have to increase your or decrease your build time. That is called BuildKit. BuildKit is still feature flagged for Linux. It is right now default on Docker Desktop. So if you're a Mac or Windows user, you have it by default with the latest versions. But on Linux, it's still feature flagged. And there is one limitation that it is only supported for building Linux containers. So you cannot build a Windows container with BuildKit. And BuildKit introduces, I think, two important updates. So what Docker did is that they just rewrote the whole build engine. And then there are two major improvements, I think. The one is that during the build, it can run parallel, so it can run parallel jobs, which saves you some time. And also the other thing is that you can mount some build time secrets, build time volumes to have your secrets. So in case you need to download something from a private repository or connect to another system with user password, now with BuildKit you can mount those secrets during the build time, use it, and then they will not ship with your image itself. And if I now build it with the BuildKit, then now the time is 35 seconds. It is faster. So far, I just, I reduced the size a little bit, and then time to build was from 1 minute to 35, so it's just half of the time. In the beginning, I mentioned that there are issues in the Dockerfile, but what are those? So, you can check online. There are many sites writing that, okay, do this, do that, etc. But there are also tools, right? So you need to, if there is a tool, you need to use it. So one tool is that HeidoLint. It's a linter. So this was the original Dockerfile, and if you run it, it will give you some recommendations. Okay, you should do this, do that, etc. Well, mainly it says that. So the main things that you need to do, from a base image, you need to give a specific version. You do not use the latest version because, well, maybe in 2 weeks there will be a new version with with some compatibility issues, etc. It says, well, there are multiple consecutive run statements. Try to consolidate them. If you use apt, then remove the list, remove the cache of the apt as well, and pin the package versions, etc. Again, because of the compatibility issues with the new release, you might have issues, etc. Same for pip. Use no cache there so that you will not have, because in the end, you will not have those deb files or Python cache files or whatever you download. You will not need those to run your application. They are just, they don't need to be within your image. So there is another issue here that, this is a Linux issue, actually. The owner of this Dockerfile used semicolons to run consecutive Linux commands. Okay, this is a way, but in Linux, if you use semicolons, it does not check the exit code of the previous command. So in this case, if apt-get update fails, it will in any case run apt-get clean and it will continue. In the end, you will see that the whole build process is successful, but actually it is not because you didn't run the apt update, etc. So you need to use double ampersands to make sure that it's logical, and if one fails, then the whole build will fail. So I listened to Heidelint and used this like Ubuntu 20.10. I used no install commands, pinned the package versions, used cachers. I combined the run statements, etc. So I have a new Docker file, and if I now build this one, it is now 26 seconds. It is even faster. And if you look at the image sizes, so I started with version 1 in 1 gigabyte, the version 1.1. So version 1.1 and 1.2 are, one of them is built with the current build engine, and the other one was with BuildKit, so same size, but second one was faster. And then the third one, this Dockerfile version 2, it is now 132 megabytes. Because I was removing the cached files which are not needed anymore, which are not needed to run my application, now the size is even smaller. And if I check it dive, if you remember from previous slides, this layer, the apt-get layer, was around 300 megabytes. Now it's 40 megabytes, just because I removed the deb files. So the time, if we check out again the time, the longest duration is to run the apt-get and install Python. It takes 18 seconds. But we all know that almost all projects have their own official images. So Python has it, Go has it, and Nginx has it. They all provide already base images with their runtime or library or whatever it is baked already into it. So why don't I use this one instead of installing Python myself? Then I use Python 3.9 Slim Buster. So also some projects provide slim images which are also a little bit smaller than the normal ones. The difference I saw, for example, the normal one, Python 3.9 one, has Git installed in it. But if you don't need Git at all, then you can use the slim image. And those kind of different tools are not shipped with slim images. So if you don't need them, you can use those ones as well. Since I did not need to install Python now, I just installed my requirements, the pip requirements, and then run it. So the Dockerfile itself is smaller. I think it looks better now. And if I build this one, it takes now 7 seconds because Now I don't run apt-get, install Python, etc. Now it's even faster. And if you look at the sizes, it's not much different. Well, in the end, we also installed Python, small, like 7 megabytes difference, but that's okay. I mean, it doesn't much matter if you install Python yourself or it was already there in the base image. So far, we talked about the size and duration, build duration, but there is also another thing regarding security. I think about security inside Dockerfile, there is only one thing that you can do, and it is actually a very important thing. Well, Docker by default runs as root, and this might be a problem. Of course, if there are any other vulnerabilities in your image. So what we need to do is to add a normal user with, well, other than root to our system, and use user directive to run our application as this user. Well, I used user ID as 5000, but it can be anything, and I said, okay, app user will run this. So if we, well, again, build it, well, the time and size will not be different. We just added one user, that's fine. But what is the difference now? So I had version 3, and this security update is version 4. I started version 3 with Docker run, then started version 4. As you see, they are running with Docker PS. But if I look at from my machine, that is the difference. One process is run by root, but the other is run by user ID 5000. In case an attacker is able to escape your container, which is a possibility which happens if you check online, there are even some demonstrations for this. If the user can escape your container, then in the first case, he or she will have root access on your server, and that's a problem. That's a big problem. In the second one, well, it will be basically nobody. Yesterday there was a keynote from Seth Vargo. He also said that, well, this is highly unlikely. I mean, it is not easy. I mean, people will not spend time for this. I mean, we'll try to log into your, to container and then try to escape from it. It's not easy, yes, but you still should be ready for it and take your actions. I think this is the only security action you can take inside the Dockerfile only. So yeah, we have now a smaller image, but there is also another Linux distribution called Alpine Linux, which they also have even smaller images. Why don't we use it? Or at least try to use it. It's the same for build time, it's 6 seconds, 7 seconds, it's almost the same. But if you check for the size, now it's 56 megabytes, it's even smaller. People reported that in the past they had issues with it because Alpine does not use glibc, but instead they use a library called muscle. If you need to compile something for your application to run in container, you might have issues because it's not 100% compatible with glibc. But in those cases, I mean, if it works for you, then you will have a lot smaller images. So yeah, we started from 1 gigabyte of image, which was built in 1 minute. Now we have 56 megabytes of image. It is built in 7 seconds. That changed things a little bit. I mean, this is the efficient part. And also think of this not running or building this container on your local machine once a day, but think of this running inside your pipeline many times in a day, running images. It is faster, and it will save your resources, also cost you less. So this was a Python application. I also want to do a Go application now. And so I do the same thing. But for Go, yeah, I use Golang, and I have a private repo that I want to download some code from there. I added the users again. And what I do was, during the build time, I send my SSH key as an argument to be able to connect to this Bitbucket repo. Well, I'm clever. I put it on ID RSA file, and at the end of the run statement, I remove it so it will not be shipped with my image. And as you see, this is the way, like as a build argument, I send the key. And but the problem here is that the size is almost 1 gigabyte. Because Golang image itself has a lot inside with the compilers, with the libraries, everything. Well, it's a huge image. To get around this, some people compile or the Go application in the pipeline and then copy the binary into the Docker itself. So they do it outside of the Docker and just copy it to the image. But don't do that. This will take you back to the "it works on my machine" problem. So because your pipeline will have some other version, the developer have some other version, etc. Always do it inside the Docker. So we have a size problem now. How are we going to solve this one? I will also mention another tool about Skopeo. It has some other abilities like converting Docker images to OCI images, etc. It's a nice tool. And you can also inspect the configuration, which can also be done with Docker inspect as well. But what I see here is that, yeah, I removed my SSH key file, but when I see here, even to add my user in the first run statement in my Dockerfile, the SSH key is sent as an argument, as a environment variable. And it is shown here like everything. So I was thinking that, okay, I used SSH key, I removed it, it's not there, but it is there. It is still there, it's in the config. So this is actually where you could have used BuildKit's build time secrets feature. This is a good way to use. Well, as I said, either you can mount your SSH key, your user password, or any other secrets. Skopeo is also able to copy your Docker image, the layers, to your hard drive as a tar file, and then you can also inspect what is inside there. And this is how people get access to the files in the different layers. You can also do this with Docker extract command as well. So I still have a size problem, and also now I have a secret problem. Secret problem might be solved with BuildKit, but the size is there. So the solution is to use multi-stage builds. So the multi-stages build is very easy. So in one stage, in one container, you do some stuff, and then the output, the artifact, whatever it is, can be copied to another container. And everything happens inside the Docker build. So here what I do is the same thing. I didn't add a user to the build stage because in any case we will copy the binary from there. And that's the container in the build stage, well, will be garbage at the end. And what I do here in the run stage, in the second stage, I copy from the builder the binary to my new container. So instead of building the Go file or Go application in the pipeline, you do it inside your Docker file. Here there's another thing that for base image I used, you may see a distroless image. So Google has it, maybe some other people do it as well. They provide even smaller images, they are called distroless. The thing is that those images don't have any package manager, so they don't have apt or yum or whatever distribution you have. And they also don't have shell, bash or sh or something. So they are smaller, you cannot log in, you cannot install some other stuff inside. But they are, well, since they are smaller and the attack surface is smaller, so you can consider them more secure than the others. Well, there's no such thing as 100% security, but you can say they are more secure than others. As you see, so the two stages are here. Well, it could be more stages. Not necessarily, it doesn't have to be 2 stages. It could be 3, 4. Some people do it like first build it and then in the second stage run unit tests or some other health checks, and then in the third stage. But in any case, the last stage will be the container that will be shipped. So with the distroless image, now it's 20 megabytes with my application plus the base image itself. If I again check it with Dive, you'll see that there are only 3 layers. The first 2 layers are from the base image from Google, and I just copied 2 megabytes of my application to inside that image, and it's just 21 megabytes. It is the vulnerability scanning is not directly related with Dockerfiles, but it will especially give you some idea about your base image, and this is important, and you have to, I mean, you are supposed to use them. It could be Docker scan now. Docker has a partnership with Cynic, and there are also open sources like Anchor, and also if you use Xfork as artifacts, it has X-Ray. I'm sure there are other tools you can, I mean, but you need to use vulnerability scanning tools, preferably first on your local machine and then definitely in your pipeline. So some examples here. This is the first version of the Go one. So without multi-stage, the first version, it says, well, Docker scan says that it found 80 issues. And with the version 2, with the distroless one, it says it found 25 issues. Well, I just removed all the issues. It also lists the whole vulnerabilities. I just removed those. If we check for the, this one is the Python one. The version 3 was that we used Python 3.9 image, Selim Buster image. Well, it says it found 71 issues. And plus, there are some alternative image types. Maybe you can use those which have less vulnerabilities. And for the Alpine one, it says there are no vulnerabilities. Well, that's also nice. Well, to sum up, what I mentioned so far is that, well, definitely use non-root user in your containers. There are, of course, other ways to force that. For example, in Kubernetes, you can say that run as this user, or even with Docker run, you can say that, okay, run as this user. But do not depend on other people if, well, someone else will run it. Just have this non-root user in your Dockerfile, in your container itself, and run it with that unprivileged user. Definitely use Docker ignore files. You don't want to ship files that shouldn't be seen by everyone. If you are not building, let's say, Windows containers, or if you don't have any other restrictions, try to use BuildKit. I believe it will be the default eventually, but you can start it already. Well, use HaloLint or any other linter to give you some ideas about what you can improve in the Dockerfile. Well, definitely always use a tag with the base image. Do not use the latest tag. or you do not depend on the latest stack, always give a version. Try to combine run statements because each run statement is another layer and it will bring you some other stuff. Plus, so let's say you created one file in one of the run statements and you removed it in another run statement. Well, that file will not be shipped, will not be seen in the final image if you run and log into that image. But if someone extracts those layers, then it will be there, especially if you have some kind of secrets or secret data inside it. You should, I mean, if you want to run a file, you have to do it in the same run statement. Well, pin the package versions with apt, yum, apk, whatever distro you are using. And definitely remove the cache files because you will not need them anymore. I mean, if you have deb files or APK or whatever distribution you have in your base image, definitely remove them. Well, you can use analysis tools like Dive, Scopio. There are other more. Docker itself also has some commands like extract, inspect, etc. Use them. Know what you ship within your container image. But definitely use multi-stage builds, especially if you have a compiled language. If you use Go, you can do the same thing with Node.js or React. You can create your artifacts from Node base image and then copy them to, let's say, an Nginx image and serve them with Nginx. This is also a way. I think it's a more secure way than running them inside a node image. Also, again, the size will be a lot less because the node will also have lots of compiling stuff or library stuff inside. Use multi-stage builds. For base images, you can use Simmons, Alpine, or Distros. Distros is especially good for, again, for compiled ones for Go applications. It will be very small. And finally, use second imagers definitely, especially in your pipeline first, in your local machine first, also within your pipeline. The earlier you are aware of the problems, the better. And that was all I want to say today, and I would get any questions.